Hi guys, we are going to do section 9.3 today. Now, I just ran through this whole video and I have to start over because the video only lets me teach for so long. So I'm going to have to do this slightly different than normal, okay? So right now what I'm going to do is, well, first I want to talk about when are you allowed to use Parachute Man. That's really important because part of the hard part of this chapter is we're going to learn so many things. We're going to learn trigonometry. We're going to learn Pythagorean theorem, which you guys already know. We're going to learn special right triangles. We're going to learn the Parachute Man. And the hard part is knowing when do you do what. And so the Parachute Man is only allowed to be used when you have a right triangle with an altitude dropped from the vertex angle with the right angle. So if you guys look at this picture here, here's what I mean by that. Here's my right triangle with a right angle. If and only if you see an altitude dropped from that vertex to the other side, that is the only time that you can use this Parachute Man trick that I'm going to teach you. Okay? Now, I wouldn't normally do this, but because I have limited time with this video, I want you guys to, in a second, I'm going to actually pause the video and I'm just going to fill in all of the variables so I don't waste time doing that. As soon as you see the variables pop up, I want you to pause the video and just copy them down, as well as copy the triangles that I'm going to put in this box here, okay? And then I'm going to have you guys like run through the actual teaching of it with me in a moment, okay? So I'm going to pause, and then you guys pause once you see all the fill-ins there. All right, so if you haven't already done so, pause the video right now and just copy in all of these letters, and then I want you to press play when you're ready to listen to me talk about some stuff, okay? All right, so here's the deal, guys. I want to make sure you understand that truthfully what's happening is three similar triangles here. They're all similar with each other. And the reason being, the reflexive, well, obviously they all have one angle in common. How do I get angle-angle similarity for all of them? Well, angle M is reflexive, right? So right now I can say that these are for sure similar. But then angle T is also reflexive. It's a part of both. So right there, now I also have angle-angle similarity. And if these guys are similar and these guys are similar, they are all similar. I know I just went through that really fast. I promise you I will clarify on Monday if you need be, okay? But the point here is that I know that triangle MIT is similar to triangle MEI. Oh man, guys, this should be an I here, not an A. I'm so sorry. So if you didn't, I'm sure you already probably picked up on that, but if not, please fix it. Triangle MEI, which is similar to triangle IET. Now, it would be a huge pain every time to draw out all three, figure out how they line up, and then pick and choose the correct ones. Now, what I want you guys to notice is, if you look at each of these, do you see how the first two both have A in common? The second two both have H in common, and then the first and the last both have a B in common. Though that's why there's a shortcut that we can use, because we can use geometric means in order to solve when it feels like there's not enough information. So here's what we're going to do right now. I'm going to talk about how we're going to use geometric means and explain the Parachute Man. So one more time, I'm going to fill in all of the variables and then pause, fill it in, and then we'll go through it together. All right, here we go. So here is what the Parachute Man means. So there's this dude, okay? I have no idea why, but he's flying in on a parachute because he's really cool like that. And he's got this parachute, and no matter what, Parachute Man is always going to land up at the big right angle, okay, every time. So you might, no matter how the picture is turned either, so you might have to turn the picture to help visualize it, but there's this dude coming in on a parachute. Now, he has no choice but to get to the ground, he's going to have to slide down one of the three pieces, either the legs or the hypotenuse. So he's going to slide down by A, he's going to slide by H, or he's going to slide by B. You have to figure that out, okay? The slide is always in the geometric mean spot. So don't forget Emmy to help you remember which one goes where. So let's kind of talk about, I want you guys to set up 3 blank proportions, 3 sets. So here's one, we're going to have a second one, and then we're going to have a third. Now, let's talk about what happens if he slides down the middle, or I'm sorry, the left. If he slides down the left, then A is his slide. So that's going to go in the mean spot. So A on the bottom left, A on the top right, okay? Now, if the slide is the geometric mean, the extremes are the closest piece, oops, let's erase that, the closest piece, and the whole hypotenuse. Okay, so let's go back to the parachute dude who slid in on the left. The closest piece is Y, the whole hypotenuse is C. So slide, closest piece, whole hypotenuse. Okay, now we're not going to do the middle guy yet. Let's say parachute man slides in on the right. Well, his slide is always in the mean spot. Closest piece is X, whole hypotenuse is C. So slide, closest piece, whole hypotenuse. Okay? Now, the only other one that's different, okay? So disclaimer here, what if parachute man comes in down the middle? Slide still goes in the bottom left, top right. So H is the bottom left, top right. But now, which one is the closest piece? Is it X or is it Y? You might be saying, well, it's evenly as close. It's right there. It's next to both. So that's how you know, since they both are the closest piece. Those are the two you use, left and right. You don't use the whole hypotenuse when you slide down the middle. So let's make a little note here. If you slide down the middle, then use left and right pieces. Okay? All right, so let's talk about something here. You might be sitting there with this burning question: how do I know which slide to use? How do I know whether to slide down the left? How do I know to slide down the middle or slide down the right? And what I will tell you is it will be very clear. You will know which slide to use based on the numbers in the picture, okay? So let's do 2 examples. I'm going to, on the back of this, why don't we do a couple examples, okay? So, problem number 1. So we have triangle, and I'm not going to label any vertices because it doesn't really matter. And then we've got C, D, and E. And let's see, what else am I going to give you here? I'm going to give you that this whole piece here is 16. Okay, so first of all, let's talk about which slide to use. Do I use the 14 or do I use the E? I'm clearly not going to use the one on the right. There's nothing even labeled there. Well, let's try it for a moment. Let's try and do the middle, because I will tell you students like the middle the best because that's the easy one. You slide down the middle and you go left, right. So if I were to try the slide right now, slide E, left is C, right is D. That is not helpful to me at all. It is literally all variables, so I'm not going to do that one. Instead, I'm going to slide down the left, okay? So 14 and 14, closest piece is C, whole thing is 16. So I go ahead and I cross multiply. 16C is equal to 14 times 14. So 196. Divide by 16, and C is equal to 12.25. By the way, guys, if you wanted to, which probably would have been smarter, especially since I don't have a calculator here with me. I could have simplified the 14 and the 16 and then cross multiplied. It probably would have been a little bit nicer. But all right, so now that C is 12.25, I'm going to take it and I'm going to plug it back in here. 12.25. And then I can now subtract 16 minus 12.25 to figure out that this is 3.75. So now you've got all the numbers you need, and you can come back to our original idea of sliding down the middle, and you can use that. So middle slide is E. The left piece is 12.25, which this is clearly a terrible picture that I drew. And then this is 3.75. So I was just moving too fast. I apologize about the picture there. So now, cross multiply, E squared is equal to, let's see. All right, guys, so before, I was just about to do the decimals on my calculator, and that's silly because I'm not allowed to round until the very end. So what I'm going to do is I'm going to find a way to make this so that it's not a decimal. So it's up to you if you want to hit Math Enter on your calculator, or I am running out of time because I want to do one more example. So I will explain the algebra behind it later, but I can get that E squared is equal to, let's see here, 735 over 16. Okay, and again, I can explain the algebra behind that later if you need to. Okay, now when I go to square root both of those sides, I end up with E is equal to plus or minus root 735 over 4, because the square root of 16 is 4. Now you would need to reduce that. Usually we don't use quite as big numbers on a quiz or test, but this is 49 times 15, so that's 7 root 15 over 4. I'm going to eliminate the negative version because I can't have a negative side length. Okay, so right now I have now solved for C, D, and E. Okay, one more problem, and then this video is all done. Okay, one more problem that's kind of a little bit trickier. I'm running out of time, so I'm going to pause and draw the picture, and then we'll go from there. And you can pause as well to draw the picture.